Hello all. Today we are going to look into the topic called as a balanced outlook on law, which is under the course called as your professional ethics. And this is going to give a gist, or we are going to run through a principle of role of law in engineering ethics. Ethics is a subject, or ethics is a word which makes everyone to do something positively that may not harm anyone. Like the same, when we enforce the ethics in law, the things that we move around, or the constructions that we run around, or the process we stick around, or the industry that we um, get in, okay, when it follows some ethical principles, there may not be any catastrophic events that may happen. But if there are, I've listed few of examples in this video, in which when the industry has been not enforced with the laws, or when they are not doing any ethical principles, when they are not following any ethical principles correctly, what are the various catastrophic events has occurred in the 19th century, 19th and 20th century. And let me see what is the need of the balanced outlook on law is. We need the necessity of law and regulation, and the limitations in directing and controlling, and the nature do not encourage the moral initiatives, and the laws are provided for minimum level of complaints. When we are enforcing with the law, when we stick on to the laws are there are two levels what the law is enforcing. One is in complete state of art facilities, and next one is in complaints up to the complaints. If for example, if we grade for up to 5, 0 to 1 to 5 means there are standards in which we can stick up to 5. There are standards in which we can stick up to 4. There are standards in which we can stick up to your 3. The 3 is called as a complaints level. Okay, your 4 is your good, and your 5 is your excellent premise. Okay, it is possible to it is possible to score 3 by giving in complaints or the minimum level of loss enforced on the process. And the balanced outlook of law, what it does is it a balanced outlook stresses the necessity of laws and regulations and their limitations in directing engineering practice. See, if we are doing our if the company is a production based company, say for example it's a foundry based company, there they'll be using some chemicals, and there they'll be using bigger muffled furnaces, tubular furnaces. So what the law will be enforcing is, when they are using some bigger furnaces and when they are using some chemicals, the chemical should have a proper storage place. And the furnaces should, if they are going with 1000 degrees centigrade and 1500 degrees centigrade, the personnel who is working near the furnace should be given some better gloves, and should be given with some better heat resistant dresses, and he should be given some proper cooling glasses to take the process up. And when there are some process in which they'll be using some acids, so there also the preparation of the acid and the usage of acid, and how the annealing should take place. These are the few processes in which the law will be enforced to take up the complaints level, such that it may not cause any harm to the lives which they are working with. So like that, it stresses the necessity for laws and regulations. In order to live, work and play together in a harmony as a society, there must be a balance between an individual need and as well as desires against the collective needs and desires. See, for example, say a concern is run by an owner. Okay, so if the in that concern, if say 5 people are working means, the concern's owner will be having some desire that on the day, on a particular fine day, that process should get completed. But whereas the 5 workers may not, if they are not given with proper facilities, then they can't achieve with the result. If they try to achieve the result without the proper complaints filled help from the management, then there occur some errors, or there occur some misbehaved situations in which there may be a loss in life, or there may be some accidents that may occur. Okay, that should not happen. Okay, so like that, what are the things that we can take care? Only ethical conduct can provide such a balance. So the course must be enforced with the help of the laws. And role of law in engineering, we should use precise rules and enforceable sanctions, and which in case of your ethical misconduct that involve violation of well established and regulated re-examined procedures that have their purpose the safety of public. For example, before starting with any process, even though if you have done with all the laws, if you are, if the your procedures are in compliance level of the law also, we have to test that with a set of known and experienced, well experienced people, to find any loopholes that is present. Okay, that should not see. We have to enforce the concept that the process should not affect the life or should not harm the life. That should be the proper mindset that we should have, because generally, basically, many industries are located out of the normal living areas, but whereas few industries, few small scale industries are located inside the city limit, also inside the urban areas also. So there, what we have to do is, some these type of practices is needed to completely stop any wrong events that may take place. It also provides a self-interested motive for most people and corporations to comply with, and reasonable minimum standards are issued of professional conduct. And the role of law in engineering, there are few other process, few other things that we have to take place. They also serve as a powerful support or and defense for those who wish to act ethically in situations where ethical conduct might not be welcome. And this is wrong to write off the rule making and rule following as ineffective. Good laws and effective enforce clearly produce benefits both for the employer and as well as employees and as well as the people who are surrounded that. And we always have in broad based guidelines to set up any industry and to work on an industry. So in area of experimentations, rules must not attempt to cover all possible outcomes of an experiment, nor must they force the engineer to adopt a rigidly specified course of action. See, for example, in areas of experimentation, say for example, if someone is working on an instrument, that person will not be given with a liberty to work on all instruments. If a person has been experienced in working an instrument, then the company will force the person, force that employee to work on the particular instrument, because he will be experienced and he had got a lot of experience in that, so he can produce an object or run that machine without any error, and that may not harm the product and as well as harm the lives which are located near to the machine. So then a few other laws in engineering are, that is called as your minimum compliance is always needed while constructing any industry, and engineers and employers can search for loopholes in the law. Okay, so what any new industry which starts, if they want to do with all the complaints, minimum complaints fulfillment means, say for example, this much money should be involved means, then the engineers and the employers will search for some loopholes which may sufficiently reduce the investment. Okay, but whereas that is not a good practice. Engineers will tend to refer to standard ready-made specifications rather than coming up with innovative ideas. See, we always should not go with the standard procedures and standard protocol. As an engineer, we should evolve some new ideas such that which should give the complaints also at minimum cost, but it should not demarcate from the level of safety which the already occurring procedures give. And this minimum complaints will lead to a tragedy such as your Titanic ship, even you all know. And continually updating laws and regulations may be counterproductive and will always make the law to lag behind the technology. This is also overburdens the rules and regulators. Many laws are non-laws, laws without enforceability, that is called as your ineffective sanctions. These frequently give a false sense of security to the public. Say, for example, there are few other process that is going around near Tutukudi and all. So, if they follow in proper complaints level means, then it could be welcome. Okay, but if they are not following a proper complaints level and they are trying to mitigate the people around them or mitigate the governments in which sanction them, okay, then that will be a problem. So the problem of law and engineering, high powerful organizations like government can violate the laws when they think they get away with it by inviting would-be challenger to face them in a lengthy and costly court proceedings. This also creates frustration with the law. See, sometimes the government personals may not look into the process very keenly. Just for eye sake and just for ear sake, they will give the permissions, But so that is also a violation. If a government office or a government member is violating the law, then the industrialist will do all wrong processes, and which may lead to many false activities to happen, and that will be a big challenge to remove in the future, and that may even cause many Breadhood challenges. See, for example, in few water resources, soap companies and paper companies will be resolving their waste, which may that in which a few smells may amount. For example, the people of Erode may face some sequences near the Bhavani and all. A few paper mills waste are getting mixed with that because of foul smell will get emitted, and also near the places of small resources, water resources, soap companies and as well as your dyeing companies will mix their waste, so which may not make the water to suit for drinking. And these are the things in which when a company is getting started, paper mill or a dyeing factory is getting started, they want to get approved from the government and government officers. The government officers may not take it up very stringently to enforce the law, so because of that the people who are nearby will are getting affected. And the next thing that we are going to study is a few examples we are going to study within this call as your challengers case study. There are three issues that happen with the challengers case study. As of challenges is about, one is your factual issues, and the next one is your normative issues, and third one is called as your conceptual issues. The challenger case study has occurred due to the o-ring failure, thermal mismatch. If you are a metallurgist, okay, or else if you are a metallurgist or a material science people, then you'll be knowing that that o-ring failure is that is called as your thermal mismatch. If say for example there are two materials, say the material, one material is say A and another material is your B. When two material, if you are making a layer of two materials, the two materials should have some common properties. At least they should have an temperature coefficient of merely equal temperature coefficient of resistance. If it is one is having a lower temperature coefficient of resistance, the next one is having a higher temperature coefficient, means then when the material, okay, of higher temperature coefficients is is the top layer and the bottom layer is your lower temperature coefficients, means when high temperature, when the material of higher temperature coefficients is facing some higher temperature, what happens is it can resist. But whereas when that is imparted to a material of lower temperature coefficient of resistance, then there exists an breakthrough between the materials, and which is the cause for the o-ring failure as of the challenges case study is about. So only the space shuttle has got demand. So the factual issues, they also involves about what is the case is about, and though they seems to be always clear and maybe controversial, and conceptual issues also the problems in various things. For example, here they've given about the problems in the pediatrics parents discussion about, these are some concepts. So here what happened is, in the previous thing I've explained about the facts, normative and as well as your conceptual. Factual means o-ring failure, and normative means it's a thermal mismatch. Conceptual means when the materials, two types of materials has been taken, one is having larger temperature coefficient of resistance, and the second one is called as your lower temperature coefficient of resistance. When the materials are exposed, when the composite is exposed to a, see for example, consider you are making a composite. In that composite, one material will be having as an acting as a matrix, and next material will be acting as a reinforcement. If the material which is acting as a matrix and the reinforcement material on it, okay, if both are having same type of nearly equal temperature coefficient of resistance, then that can successfully act as a material of high Young's modulus and high Poisson ratio. But whereas if one material is having a lower temperature coefficient of resistance and the next one is having a higher temperature of coefficient of resistance, when that material is exposed to temperature, then what happens is the matrix and reinforcement, there will be a break in the between the materials of matrix and reinforcement, such that which is the cause for the o-ring failure. And the risk benefit analysis and reducing risk is to design or to decide on the design and advisability of product, and to study and modify the design. Both risk and benefit lie in the future, to know risk and benefits and weigh them each. And next type of discussion is your Bhopal gas tragedy, and this is called as Bhopal gas tragedy. It's an company or so for which license has been given to make a methyl isocyanate based pesticides. They were not having a proper engineers to work, proper engineers and proper laymen to work, so lack of experienced personnel to operate and control the vital installations. And about 600 people died and left 7,000 people injured, and the health of about 2 million people was affected adversely because of the tragedy. So, and this is the tragedy place location, and it's the company is the plant is called as your Union Carbide pesticide plant in Bhopal, is which happened in 1984. It has now given rise to another controversy. See, because of the Bhopal gas tragedy, the entire place cannot be used properly, and the people who are surrounded that Union Carbide pesticide plant have been with are with ill. Okay, still now few of the generations are facing that toughness. And next one is your Chernobyl case studies, and this is the acronym for this is like a nuclear reactor. Okay, acronym for your water cooled and graphite moderator based reactor were used. 30 workers in the complex lost their lives, and the agricultural products were affected due to contaminated radioactive water for several years. 8,000 people lost their lives. And this is the biggest tragedy, and it has been given. So still now to close it, what they have made is in the radioactive metals cannot be removed very easily. Instead, what they have made is they have made some casing around this Chernobyl this reactor, which is completely ghost, even though few radioactive substances will get emaned out of the aging. Okay, so safety and risk, functions of safety system components, and we have to do before starting with kickstarting with any progress. We have to do some destructive testing, prototype testing, and simulation testing is needed to make our system to be a reliable system which may not affect the life. And this is a trend that has been shown. Okay, so your risk and safety trends, and as well as your work safety, an employee always needs the safety of the workplace, and it should be off from the hazards, and it should be within good health, and it should be within collegial work environment and everything. Okay, so this is the trends. Okay, of for example braking, so for example when we drive a car. Okay, what are the safety habits that we should do is we should wear a seat belt, and your braking habits and your over acceleration should be avoided. After hours vehicle usage should be minimized, and your sharp cornering should be avoided, and the speeding should not be high. Okay, this may not give you any problem to you on driving, and this may not risk your life too. And assessment of safety and risk, new applications of absolute technologies, uncertain behavior of materials, restricted access to knowledge on risk, and estimation of risk complex. For example, new applications of absolute technology means you example you take for example new technology evolution should be taken as an engineer. We should not follow the old technology itself, and effective and good result producing technologies that we have to use, and uncertain behavior of materials. So for example, I told that o-ring failure challenges case study, restricted access to knowledge and risk. So that means poor experienced people when they are used, means that's your global gas strategy, and your tragedy, and your estimation of risk complex. If a risk happens, what is the impact? If each and every employee of the concern should be known with that, they have to be given sessions with that, so everyone will be more proactive in their work. And the industrial standards how we have to follow is, so industrial standards means they will be setting a criteria, they'll be having a standard functioning and operation procedures, and they have to carry out the operations in their respective fields of production. And industrial standards are generally accepted requirements, and it provides a orderly and systematic formulation, adoption, and application of standards. And they are also used for developing and meeting industry goals. Industrial standards will always facilitate global as well as domestic competitiveness. It's used for developing and meeting industrial goals, which is the crucial tool for everyone. For example, in automotive industry, the tire size and durability. See, if the tire is very much wide, means then if the tire is very much wide, then what happens is the interaction between the road and the tire will be more. Okay, then the friction that is produced is also more. As of kinematics is concerned about, okay, as of kinematics is concerned about, when the friction is more, okay, then the loss of the tire will also be more. So the tire size adjustment and as well as your material that is used to make the tires will be time to time they used to do some R&D such that which may give the durability and the long lasting for the tires. And standardization serves as a quality check for any type of industry. And examples of your industry standards are I've given with so there are few other societies which give some suggestions and which gives some uh, examples of how industry standards should be built. So for example, your institute of electrical and electronics engineer is giving an institute of civil engineering for civil purposes, and national society for professional engineering, and american society for mechanical engineering, and an institute for institute of industrial engineers. So everyone is commonly saying with an thing that each and every process that we follow should have a good concise on the safety, health, and welfare of the public, and as well as okay, it should enforce the professional duties properly, and it should give okay a fidelity serving with fidelity to the public and the employees and clients, and it gives an impact of the welfare of the public all the time. So and such that it is giving a responsibility to the public goods. And role of industry standards, few other things are okay, standardization of facilities, a healthy competition, and designing a new concepts, and administrative and legislative bodies are benefited by the industry standard, and optimum standard facilitate the creation of political as well as business related advantages. In a nutshell, okay, so acquiring industrial goals related to managerial, technological, and as well as political, okay, is the importance of the industrial standard. And as of research is about, see, we have seen few faults that has occurred in when we don't have a balanced outlook on law. Few catastrophic events have happened. So what how we can streamline our ethics to follow a process such that it should follow the law, and it should lease out or it should give an idea how an error cannot occur and how it could be stopped, or how at final stage we can act and react. So like that, the research uh, be a tool to overcome that. So research ethics involves the application of fundamental ethical principles, and this include design and implementation of research involving scientific misconduct such as your fabrication of data and plagiarism and whistleblowing, etc. And first, the three things that it does is first it promote the aims of research. For example, prohibition against fabricating, falsifying, or misrepresenting research data, promote the truth and minimize the errors. Second, ethical standards promote the values that are essential to collaborative work. And third, many of the ethical norms helps to ensure that researchers can held accountable to the public. Okay, and fourth one is ethical norms in research also help to build public support for research, and people are more likely to fund a research project if they can trust the quality and integrity of the research. Finally, many of the norms of the research promote a variety of other important and moral and social values such as your social responsibility, human rights, and compliance with the law, and public health and safety. Thank you. And finally, see, I see a few students who may be having an idea to be as an entrepreneurs. When you be as an entrepreneur, when you start with any industry, be ethical, be in a progress that whatever your company may be. If your company is a productive based industry, give best order for the safety and uh, safeness of the employees who are enrolled with you, okay, and as well as safety of the public. Always being as an industrialist, okay, being as an industrialist, everyone will be having an idea of your CSR, corporate social responsibility. If we are responsible inside your company, and if you are not doing any null to the public and as well as your employees, that is the biggest CSR activity that you does. And thanks for listening. Thank you.